Hello, my name is Jahnavi and I am from CSE 4. Today we'll be discussing some fundamental computer science concepts. Those are user mode, kernel mode, system calls, compiler, interpreted, and Java virtual machines. These concepts are crucial in understanding how programs interact with an operating system and how programming languages work. Let's get started. When a program runs on a computer, it operates in one of two modes. Those are user mode or kernel mode. User mode is where applications like web browsers, text editors, and games run. Programs in this mode have limited access to system resources to ensure security and stability. These cannot directly access hardware like memory or the CPU. In kernel mode, on the other hand, is where the operating system's core components run. This mode has complete access to system resources, allowing it to manage memory, process, and hardware. For example, when you type in a Word document, the Word application runs in user mode. However, if the application needs to save a file, it requests help from the operating system, which operations in kernel mode to handle disk access securely. Coming to the system calls, since programs in user mode cannot directly access system resources, they rely on system calls to communicate with the OS. A system call is a request made by a user program to operating system for performing tasks like operations, process management, and device control. Some of the system calls include read and write functions for file operations, fork for used to create a new process, exec used to run a new program inside an existing process. For instance, when you open a file in text editor, the application makes a read system call to request data from the hard drive. The OS running in kernel mode processes this request and sends the data back to the application. This separation ensures security and efficient resource management. Programming languages use either a compiler or an interpreter to convert human readable code into machine code. A compiler translates the entire program into machine code before execution. This makes the execution process faster but requires time for compilation. Once compiled, the process can run independently without needing the source code. Examples include C, C++. An interpreter, on the other hand, translates code line by line while the program is running. This makes execution slower but allows for easy debugging since errors are detected immediately. Examples include Python and JavaScript. For example, imagine you're reading a book. A compiler is like translating the entire book before reading. Once it's translated, you can read it smoothly. An interpreter is like translating each page as you read. It's slower but allows adjustments on the fly. Both approaches have their use cases, such as compilers are great for performances, while interpreters are used for rapid development and debugging. Next, coming to the Java virtual machine. Java programs rely on Java virtual machines to run on any program, making a Java platform independent language. The JVM works by taking Java source code and converting it into Java bytecode. This bytecode is then interpreted or compiled by the JVM into machine code for the specific system it's running on. So the key features of JVM include platform independence, which is the same Java program can run on a Windows, Linux, or Mac without modification. And the second one is memory management. Like Java automatically handles garbage collection, ensuring efficient memory usage. And the third one is security. Java programs run in a controlled environment to prevent unauthorized access to the system resources. For example, when you read a Java program, it doesn't interact directly with the operating systems. Instead, the JVM acts as a middle layer, ensuring the code runs smoothly across different platforms without needing any changes. విద్య నేను కంక్లూజన్ పెట్టడం మర్చిపోయాను విద్య లాస్ట్ స్లైడ్
నేను కంక్లూజన్ పెట్టలేదు.
పెట్టలేదా
పెట్టలేదు.
ఓకే ఫైన్ అయితే ఇప్పుడు అది ఎక్కడుంది
ఎక్స్‌పోర్ట్ ఫైల్ ఎక్స్‌పోర్ట్